All right, folks. The next thing that we want to talk about is still more transformations. In this case, translations. But this time I want to talk about horizontal. We just got done talking about vertical translations. So if I take a function like y equals x squared, come on now, and instead of trying to shift it up and down, I want to shift it left or right. That's going to be a very specific type of manipulation. So here's our base curve. Y equals x squared. It goes through those same key 5 points that we've been harping on over and over again. Here's y equals x squared, and this is 2, 4, 1, 1, 0, 0, negative 1, 1, negative 2, 4. And of course there are more, but those are the key ones that I'm using for my guide points. And that's y equals x squared. That's the base graph. Now what we're going to do is we're going to take a look at something like f of x equals something like x minus 2 squared. So this is a little bit different than what we've done before. I am now subtracting 2, not from the output, but from the input, from the x value. And that's not going to change things vertically. It's going to actually change things horizontally. So let's take a look at that. So we'll use those same x values, negative 2, negative 1, 0, 1, and 2. And now when I plug in negative 2 here, and I subtract 2 more, I'm going to get negative 4. And negative 4 squared is 16. When I plug in negative 1, I'm going to get negative 3 squared. That's going to be 9. When I plug in 0, I'll get negative 2 squared. That's 4. When I plug in 1, I'll get negative 1 squared. That's 1. And when I plug in 2, I'll actually get 0. So what's happening here? Well, it used to be that when I plugged in 0, I got 0. Now I have to plug in 2 to get 0. And when I plug in 1, I get 1. Oh, it goes through that same point. That's weird. When I plug in 0, I get 4. When I plug in negative 1, I get 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's practically off the chart there. And this curve looks like this, which is really mirroring what's going on the black curve. It just looks like this point has been shifted over to, this point has been shifted over to, this point has been shifted over to. And if I were to continue on here, 3 and 4, I would see that this is 1 and this is 4. And so I would have more points here. This would be here and this would be here. And my parabola would continue on the right side and continue to grow and go up. And I could see that this would be just a continuation. That point is shifted. That point is shifted. And so all points shifted. And this is important. 2 units to the right. So how would I get them to be shifted to the left? Well, in general, I would have to do something like this. Maybe g of x is equal to x plus 3 squared. In this case, this would be shifted left 3 units. All points shifted left 3 units. And what would that look like? Let me see. I'll get a purple here. 1, 2, 3. It would look like that, that. These are getting kind of like crowded pictures here. But you get the idea. So this is backwards 3, which is counterintuitive to this plus sign. So what we do when we talk about the general form here, and this is where it gets a little bit confusing for a lot of students, so pay attention. In general, for f of x equals x minus h squared. So the first thing I want you to notice is we're writing this in terms of the general form having a subtraction here. So when we read h, if h is positive, shift right. If h is negative, shift left. So let's be really clear about this. Please pay attention. The first one was f of x was equal to x minus 2 squared. So because this formula inherently has a negative sign in it already, h is just the value 2 here. So here, h is equal to 2, which is positive, which means shift right 2 units. Whereas in my second example, which I didn't actually graph, g of x is equal to x plus 3 squared. And in order for me to rewrite this as a minus sign, and it's not, I have to be a little bit clever with my algebra. I have to rewrite this as x minus negative 3 squared. And so in this case, h is negative 3, even though it's a positive 3. Up here in this form, when I rewrite it as subtraction, it's x minus a negative 3, which means that this is a shift left 3 units. So a good way to remember this is inside the parentheses, it is opposites. That is to say, when you're shifting up and down, if you have something of the form f of x equals a, which is my vertical scaling, times the quantity x minus h squared, which is my horizontal shift, plus k, which is my vertical shift, positive k goes up, but a negative k goes down. Or I should say, this is when k is greater than 0, and this is when k is less than 0. But when h is greater than 0, this goes to the right, and when h is less than 0, this goes to the left. Which does make sense, except for, and this is, at this point I'm babbling too much about it. I'm just talking about this value without the minus sign here. So be careful there. And then for A, that's our vertical scaling that we had talked about previously. So at any rate, that's horizontal and vertical translations. Let's go ahead and do another example. Example number, I guess this is example 2 at this point. Let's do something like graph f of x is equal to 6 minus x plus 4 squared. Okay, well, the first thing that we want to do is put this in the form, if we can, a times x minus h squared plus k. That's our goal. This is sometimes called vertex form. Sometimes it's called standard form as well, but we're going to go with vertex form. And we're going to talk about why it's called vertex form in just a second. So let's rewrite it in that form. The first thing that we might do is think about this a little bit differently. This is a little bit confusing how we're looking at it this particular way. So let's go ahead and rewrite this as negative x plus 4 squared and a positive 6. That's better. And so now I can rewrite this one more time as negative 1 times x minus negative 4 squared plus 6. And that's going to allow me to identify all the pieces of the puzzle here. Here, a is negative 1. H is negative 4. And K is equal to 6. So what does that tell me? Well, we're going to start off with the basic graph, and this is going to be reflected across the x-axis, or flipped upside down. This is going to be a shift left 4 units, and this is going to be a shift up 6 units. And I suggest you do them in that order. So let's take a look at how that's going to go down here. So let's start off with something nice and big. Maybe that's good right there. So our basic graph goes through 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. And again, I'm always going to kind of start these problems with this basic model. Getting pretty good at that, right? And this is y equals x squared. The next thing I'm going to do is I'm going to first flip this across the x-axis. So what's that going to look like here? Let me see if I can color coordinate this. Well, those are too light. Hold on a second. I need a darker color. Let's go with a darker purple. That's better. And so, yeah, it's all Stranger Things right now in the upside down. That looks like garbage. I'm going to try that again. Come on, Brent. Is it Brenda? I can't remember what her name is. Brenda? I think that was her name. Anyway, this is y equals negative x squared. So we've taken care of the fact that we have an a equals negative 1. This was from the a equals negative 1. The next thing that we're going to do here, apparently in yellow, that's going to be a terrible color. I'm going to do that in orange, is we're going to shift everything left 4 units. So the origin will go to the left 1, 2, 3, 4. This point will go left 1, 2, 3, 4 units. The next point, 1, 2, 3, 4. I know that you can't really see what I'm doing here, but I'm going to each one of these points and counting to the left. 1, 2, 3, 4. And 1, 2, 3, 4. I'll put us right back there. And then I'm just connecting these again in a very smooth motion. Real smooth. Nice and smooth. And so that has then been shifted left. The first one was reflected down, then shifted left. And the purple, or the orange guy here, this is y is equal to the negative of x plus 4 squared. That's kind of hard to look at. And then the last thing that we need to do, so here, let me go back here to my color coding. We've taken care of that. That was the h equals negative 4. And the last thing that we're going to do, and apparently we're going to do it in blue here, is shift everybody up 6 units. So I'll take this guy here and I'll shift it up 1, 2, 3, 4, 5, 6 units. And then I'll take this guy and go 1, 2, 3, 4, 5, 6. And his doppelganger, 1, 2, 3, 4, 5, 6. And maybe even these last two, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And again, I will smoothly connect the dots in this parabola shape. And this point right here, which was 0, 0, got flipped upside down, which is still 0, 0, shifted left 4, and then up 6, and that makes this the point -4, 6. And there's something that we want to say about that particular ordered pair. If we look at this equation, remember that it was called vertex form when we had it in this form. And it's called vertex form because -x plus 4 squared plus 6, we can look right at this and say h is -4 and k is 6, and that's what's called the vertex of the parabola, the highest or lowest point, depending upon whether it opens upward or downward, it's been reflected or not. So, one way to do these problems a little bit faster is to readily identify that vertex and then simply take a look at the a value and how things have been stretched out. For example, let's do an example 3 here really quick. Just jam it in the corner here. Example 3. Graph something like f of x is equal to x minus 3 squared plus 2. Well, if you can look at that and you can tell me what the h, k, and a values are, if you can say, well, a is 1 because there's no real value there, and h is 3 and k is 2, that means that the vertex is 3, 2, and because this is positive, this has not been stretched or flipped. I should be a little bit more careful with what I say there. Because it's positive, it hasn't been flipped. And because it's 1, it hasn't been stretched. Which means that if I want to graph this quickly, I should be able to do it. It should be the basic parabola shape, but now it has its vertex at 1, 2, 3, 1, 2. What was the point 0, 0 is now the point 3, 2 because it's been shifted right and up. And that means that the next 2 points are here and the next 2 points are there if you remember this basic shape really well. If you have the vertex, the next points are over 1, up 1, and then over 1, up 3 to get to the next points as long as you have not been stretched or flipped. And so that allows me to just very, very quickly graph this parabola. So that is f of x equals x minus 3 squared plus 2, which, by the way, if you multiplied that out, would be x squared minus 6x plus 11, which means that if you know how to complete the square, as we're going to do in the next example, you can start with this form, complete the square, put it into vertex form, and then graph these very quickly. And that's what we're going to do in our next example.